In this video, we will talk about how to find the possible lengths of the third side of a triangle. So it helps if we know the triangle inequality theorem. This says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So for example, if we have some triangle with two sides, and let's just say this side is 10, and let's say this side is 5. And if we want to know the possible range of values for this missing side, let's call it x. This theorem says these two sides right here have to be greater than x. So 10 plus 5 must be greater than x. Or another way to say that is that x must be less than 10 plus 5. So let's write that right here. X must be less than 10 plus 5. At the same time, this smaller side plus x must be greater than 10. So let's write that. X plus 5 has to be greater than 10. And if we want to solve for x here, we could just subtract a 5 from each side. So we can really say x has to be greater than 10 minus 5. So here are the two rules. X has to be less than 10 plus 5, and x has to be greater than 10 minus 5. Now, if we want to generalize this rule, let's say we call this side A, this 10, and let's say we call this side B. What we can say is x has to be less than A plus B. So let's write that right here. X has to be less than A plus B. And at the same time, x has to be greater than a minus b. So we'll say x is greater than a minus b. So here is the rule that you can always use to find the possible range of values for x, the third side of a triangle, if you know the other two sides, a and b. So let's use this rule to work through a few problems. All right, let's check out this problem. It says two sides of a triangle have the following lengths, 9 and 5. Find the range of possible lengths for the third side. So all we have to do is use this formula that we just found. So if we call this side, this 9, let's call it A, the larger length, and let's call the smaller length B, and we can just plug these values into A and B in this formula. So we'll say A minus B, so 9 minus 5 is less than x, which is also less than A plus B, so 9 plus 5. So we get 9 minus 5 is 4. So we'll say 4 is less than x, which is less than 9 plus 5, that's 14. So here is our final answer. X can be between the values 4 and 14, not including 4 and 14. So these are the possible range of values for this third side of the triangle, if we know that the other two sides are 9 and 5. All right, let's try another example. Let's say two sides of a triangle have the following lengths, 11 and 8. Let's find the range of possible lengths for the third side. So again, if we call the larger side A and the smaller side B, we can plug these two values into this formula. So we'll say A minus B, so 11 minus 8 is less than x, which is less than A plus B, so 11 plus 8. So we get 11 minus 8 is 3, is less than x, which is less than 11 plus 8, that's 19. So x can be between 3 and 19. But not including 3 and 19. All right, let's try one more example. Let's say two sides of a triangle have the following lengths, 5 and 5. Find the range of possible lengths for the third side. So if we call this side A and we call this side B, notice that they're the same value this time, so it doesn't matter which one we call A and B. We'll just plug these into the formula once again. So we get A minus B, so 5 minus 5 is less than x, which is less than A plus B, so 5 plus 5. So we get 5 minus 5 is 0, is less than x, which is less than 5 plus 5 is 10. So x must be between the values 0 and 10, not including 0 and 10. So this is the formula that you can always use to find the possible lengths of the third side of a triangle. If you know the other two sides, A and B, we know that x is going to be greater than the difference of those two sides, and it's going to be less than the sum of those two sides.